Okay, today we're going to take a look at solving trig equations, part B. This is going to get a little bit more complicated. On the last example that we're going to do, I'm going to use the Pythagorean identities. You can refer to a video before this to see how we use them and how we come up with them. So let's go ahead and start. So it says solve, and then they want us to figure out a solution between 0 and 2 pi. And at 2 pi, it's important that you know that this cannot be a solution because it's not equal to. 0 may be a solution because it is equal to. And then they want us to find all the solutions. So let's go ahead and begin. Okay, so this is going to be a little bit more complicated from what we're used to, but that's okay. We're going to use basically algebra. That's why it says analytic for the title, to solve. So let's go ahead and let's note that there is a typo. This should be x. Okay, we're ready. Because I have a binomial here, I have sine x minus 2 sine x times cosine x. I can simply divide out a sine x. Remember that I have it equal to 0, so I'm feeling like we probably have to use the zero product property here. So if I factor out a sine x, that leaves me with 1 minus 2 cosine x is equal to 0. And now I simply, using zero product property, break it into two pieces in this case. Sine x equals 0. And let me grab another color for my other piece. 1 minus 2 cosine x equals 0. Okay, we're in great shape here. Alright, so for the one in red, I'm going to try to isolate cosine x, so I'm going to subtract 1 from both sides. I get negative 2 cosine x is equal to negative 1. I then divide both sides by negative 2, and I get cosine x equals positive 1/2. Okay, so let's draw our little unit circle, at least the first quadrant. And if I do that, I get pi over 6. Next one would be pi over 4. And then we have also pi over 3. My order pairs, so I'm going to do them in a different color here. Remember, our little trick works really nice. This should be parentheses, 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 count 1, 2, 3 down, 1, 2, 3 up, stick it all over 2. And don't forget to take the square roots of the tops. Okay, now remember, cosine deals with the x, sine deals with the y. It looks like the only thing that I have that's equal to 1/2 is at pi over 3, 60 degrees. So one of your solution is x equals pi over 3. Now this is a special type of x because it's in the first quadrant. It's x prime, meaning reference angle. Okay, let's go to sine x equals 0. Okay, so where does this happen? If we look on our makeshift unit circle, we know that this order pair here is basically 1 on the x-axis and 0 up. So this would be the only location at 0 radians. So x equals 0. So let's go ahead and let's see if we can come up with other solutions, because remember, we want solutions from 0 to 2 pi. Okay, so for cosine x equals 1/2, we can draw out all students take calculus. We know that this also occurs in the fourth quadrant, so I'm going to basically use my plus minus trick. This means I'm going to take 2 pi minus pi over 3. And what I'm going to do now is I'm simply going to find the least common denominator. It's 3, so this would make 6. And I know that I also have a solution in the fourth quadrant that's 5 pi over 3. Okay, so we've got 1, 2, 3 solutions. Remember, I'm allowed to use 0 because 0 is equal to theta, or in this case, to match all our variables, x. Okay, so is there anywhere else where sine is equal to 0? Yes. So let's think about this. If we were to sketch it, just a quick little sketch, 2 pi half of that is pi, half of that is pi over 2. Average pi and 2 pi, you get 3 pi over 2. And for sine, we have 0 here. It goes up to 1. We get 0 at pi, goes down to -1, and then 0 again. So the sketch would look like this. Got to make the noise. So it looks like we have one solution here, we have one solution here, and one solution here. So another solution would be x equals pi. Now the last solution at 2 pi doesn't work because it's not equal to. So you have 1, 2, 3, 4 solutions. Now if they wanted all the solutions, remember what we would have to do here. X equals 0 plus 2 pi k. X equals pi plus 2 pi k. And I didn't mention this in an earlier video where k is an integer. So if it's a fraction, it's not going to work here. Let's finish it up. So x equals pi over 3 plus 2 pi k. And last but not least, x is equal to 5 pi over 3 plus 2 pi k. Now I know that seems like a ton of solutions. However, in a later video, I'll show you how to narrow this down, if you will. And remember where k is an integer. Okay, let's take a look at example 2. It says solve 2 cosine squared theta plus 11 cosine theta is equal to -5. Okay, so on this one, I don't think I'm going to have to use my Pythagorean identities because I'm given everything in terms of cosine. First question says all the radians, find them. Okay, so no worries. Let me see if I can try to factor this. So I have 2 cosine squared theta plus 11 cosine theta. And let me go ahead and add 5 to both sides. I want to do that because I want to get 0 on one side. So plus 5 is equal to 0. Okay, so now I could use zero product property if I had a product. So let me see if I can factor this. 2 cosine theta. And because I have plus plus, it's going to be plus. And cosine theta plus. Now I have to find two numbers that multiply to 5 and then add up to 11. And remember, I have this this number 2 right here. So I'm going to say if I put a 5 here and a 1 here, if I multiply 1 times 5, I get 5. And if I multiply and I FOIL or distribute, 2 times 5 makes 10, plus 1 will give you your 11, is equal to 0. Okay, so now let me grab another color. And because of zero product property, I can say 2 cosine theta is equal to, oh, almost made a mistake there. Let me erase here. 2 cosine theta plus 1 is equal to 0, and cosine theta plus 5 is equal to 0. If I solve the one on the right, I subtract 5 from both sides. I get cosine theta is equal to -5. Remember, this can't occur. You can't have a height bigger than 1 in this case. So no solution set. On the second one, I subtract 1 from both sides. I get 2 cosine theta is equal to -1, divide by 2, and I get cosine theta is equal to -1/2. Now, as you can remember, in the first quadrant, I don't have any negative values for any of the trig functions. So we're going to have to see where I can generate a negative. All students take calculus. So it looks to me like the second and third quadrants are where cosine can be negative. But let me at least find the reference angle. The reference angle, if I go back up, okay, it looks like it's going to be at pi over 3 again for cosine, because that's equal to 1/2. So that's not a solution. That just gives us a little reference on what to look for. So if I wrote this correctly, it would be pi over 3 would be the reference angle. So if I want to find what it's like or what the answer is in the second and third quadrant, let me grab another color. I would just use plus, minus, plus, minus. So this would be, in this case, pi, and I would basically say pi minus pi over 3 to find the solution in the second quadrant. Least common denominator is 3. That makes 2 pi over 3 would be a solution. I'll circle that. And then for the third quadrant, I would say pi plus pi over 3. I would have a least common denominator of 3 again. That's 4 pi over 3. That would also be a solution. And so here to answer our question, we basically have theta is equal to 2 pi over 3 plus 2 pi k, and 4 pi over 3 plus 2 pi k. In terms of part B, we've already solved it. We know that theta is equal to 2 pi over 3, and theta is also equal to 4 pi over 3. It's not uncommon that the reference angle isn't a solution. It's okay, you're not wrong. Let's take a look at the final example here. Now this is the example where we're going to use our Pythagorean identity. Now remember, it's sine squared theta plus cosine squared theta is equal to 1. And the reason why we're using it here is I can see that I don't have everything in terms of sine or cosine, so I'm going to probably have to use the identity right there. So if I rewrite this, I know that if I subtract cosine squared theta, that's equal to sine squared theta is equal to 1 minus cosine squared theta. So I can use this identity. So if I rewrite this, you'd have 2 times the quantity 1 minus cosine squared theta minus 3 cosine theta minus 3 is equal to 0. Okay, so let me distribute that 2, and we'll see, maybe we can get away with factoring here. So 2 minus 2 cosine squared theta minus 3 cosine theta minus 3 is equal to 0. I'm going to combine like terms, so I get negative 2 cosine squared theta minus 3 cosine theta. And then here, negative 3 plus 2 makes a negative 1 is equal to 0. I don't really feel like having this negative here, so what I'm going to do is I'm basically going to multiply the whole thing by negative 1 and just distribute it all the way through and even to 0. And so I'm going to clean it up to have a nice positive number here. 2 cosine squared theta plus 3 cosine theta, and then in this case plus 1 is equal to 0. Okay, let's see if I can factor. That would be really nice in this case. If I can try to factor, it would be 2 cosine theta plus, and then cosine theta plus. Okay, I need two numbers that multiply to 1 and add up to 3. Now, the nice thing is, if I put a 1 here and a 1 here, it multiplies to become 1. If I distribute, I'll notice that I will generate that 3. So this is equal to 0. Now I can use the zero product property. 2 cosine theta plus 1 is equal to 0, and cosine theta plus 1 is equal to 0. And if I subtract 1, I get cosine theta is equal to negative 1. On this one, if I subtract 1 and divide by 2, I get cosine theta is equal to negative 1/2. We already know this solution from the previous example. For this solution here, we know that it's going to be 2 pi over 3 and 4 pi over 3. So theta equals 2 pi over 3, and theta equals 4 pi over 3. And in this one, if I look at my unit circle, I know that I have order pairs here, and we're looking for a negative cosine, so the x-axis being negative. So that's definitely negative 1 comma 0 here, and that's the only location, so at pi. So I have theta equals pi as a solution. Now I believe they wanted all the radians, so I'm simply going to, because it's cosine, add plus 2 pi k plus 2 pi k plus 2 pi k, and those are your three solutions. Okay, so our learning goal, students will be able to solve trig equations. With a little bit more practice, I believe you will be able to. I'll see you in the next video.